concept of the initial value theorem and a final value theorem, which is come under the Laplace transform. So if you are new on my channel, so don't forget to subscribe, and if you have visited in first time, so subscribe now to get the latest video on my channels. On so let's proceed our discussion of Laplace transform. What is the final value theorem? Initial value theorem is stated. Initial value theorem. Okay, if so here I have written the initial value theorem. If f dash t is the function, if dash t exists and it is the piecewise continuous, and on every subinterval t as t greater than 0, it is the and if it is the function of a class A and order exponential order as t tend to infinity, then we have this. So what I have written now, we are going to prove it. So proof. Here we have a proof. We know that Laplace transform of f dash t is what is equal to 0 to infinity est f of t dt. Since Laplace transform of f dash t is what we know as Laplace transform of f of t minus f of 0. Okay. So now putting this value here, we get 0 to infinity est f of t dt equal to as f of t equal to f of 0. Now taking the limits at t tend to infinity. Now taking the limit. Now taking the limit as tend to infinity. So we get 0 to infinity est f of t dt equal to s limit f of t tend to infinity limit f of 0. Okay, so that is since we have a s tend to infinity, so this function will get 0, because when we get and it is the function of a class, when we find the limit of a function, you will easily find it will give us 0. So that means s tend to infinity as Laplace transform of f of t s equal to Laplace transform s 0 f of 0. Okay, here I am writing here that when we will give that, it gives us t tend to infinity f of t. That is our proof of the theorem. So I think you have to understand how to prove it and what will be the value of this. So this is where we have to prove the initial value theorem. Now I am going to move final value theorem. let's final value theorem. So that is our theorem. The difference between as if you see the initial value theorem here, s tend to infinity, t will give us zero. Okay, so that is the reverse of the initial value theorem. So we have to prove it. Since if f dash t is continuous, so we have Laplace transform of f dash t. We know what is as a Laplace transform of f of t minus f of 0. Okay, since Laplace transform of f dash t equal to 0 to infinity est f of t. Okay, now we have to 0 to infinity est f of t dt equal to as Laplace transform of f of t minus f of 0. Now taking the limit as tends to infinity, now taking the limit as tend to 0, so that give us 0 to infinity est f of t dt limit as tend to 0. So as limit f of t limit t as tends to 0 into limit as tends to 0 f of 0. When we find the value of this, that give us f of t f of t 0 to infinity. Okay, 0 to infinity, and after equal to this I have now space here, so I am writing here. So limit s tends to 0 f of t f of 0, so s tends to 0, that give us limit t tend to infinity f of t equal to limit s tends to 0 f of s. Okay, that is our proof. So we have proved the initial and final value theorem. Now we are going to the next. I think you have to understand how to prove it and what is the concept behind the initial value final value theorem. The only difference between the initial s t tend to infinity here has s tend to 0. In the initial value s t tend to s tend to infinity, t tend to 0. That is the reverse we have. Now we are going to find some important special Laplace transform of a function. Now I am going to find a Laplace transform of periodic function. Okay, what is periodic function? So first, if you don't know what is periodic function, I am telling you, if ft plus a equal to f of t. Okay, here a is period, then ft is said to be a periodic function. Okay, what is periodic function? Suppose since sin x is a periodic function, so how to find it? So sin x, if we write it Sin x is how to period. Pi plus x equal to what? Sin x. 2 pi. 2 pi x equal to sin x. So here period is what? Period is 2 pi. What is periodic? Based on the periodic function, we have a simple harmonic motion. Harmonic motion. I am not going to detail here. We will cover. So that is the type of periodic function. What is the periodic function? Now I am going to find the Laplace transform of a periodic function. I think you have to understand. You have understand how to find what is the periodic function. So obviously ft is continuous differentiable stable. So now we know that Laplace transform, suppose ft is periodic function, okay. So Laplace transform of f of t is what? Is 0 to infinity est, okay, f of t. Now okay, f of t dt. Since f of t is periodic, so 0 to infinity est f of t plus dt. So I am breaking into two parts, okay. Since here is an interval here, so we can write is 0 to a est f of t plus a dt plus, okay, a to infinity est f of t plus a dt. When we find the value of this, you will get the value one minus est as a 0 to infinity, 0 to a est f of t dt. So that is our the Laplace transform of a periodic function. So find the periodic function, find the period Laplace transform of t greater t square. What is? Find the Laplace transform. I am giving us, you have to do it. So Laplace find the t square f of t where t greater than 0 less than 2. So that is you have to find. Here we have an interval that is 0 to 2. So find the interval when the period is what? Period is 2. So Laplace transform of f of t is what will be? 1 minus s e s 2, 0 to 2 e s t. So e s t e s t e s t e s t f of t is what? T square dt. Obviously you can find it, so there is nothing problem. So I have done it, so I'll move in the next part of this topic. So here, if you get enjoy and get some information, do like, share, subscribe now. Thank you for watching me again.